For this week, I made an experiment using our 7.6 centimeter wide heatsink with a length of 29.5 centimeters. I used for this test a COB LED that is rated at 50 watts, and the temperature was measured at two different points, T1 marked here and T2 at a distance of 10 centimeters. This is a complete image of all the types of dissipation that I used for these measurements. There are three cases: no fan, a fan of 20 CFM, and a fan of 40 CFM. I put here the ambient temperature so you can have a reference for the temperatures taken by the thermal camera. The temperatures that really interest me are the ones taken by the thermocouple, and I will address this at this moment. In this table, I show the temperature that I measured in each experiment. This line corresponds to no fan, 0 CFM, this line to the 20 CFM, and this line to the 40 CFM. The most important difference between the experiments using the fan and the one using passive dissipation, also meaning no fan, is that there is a difference in the electric power consumed by the LED. When I use the fan, the power is about 62 watts, while when not using the fan, the power is about 47 watts. The difference in light emission from a visible point of view was also evident, because at this power the LED did emit less light. This difference allows me to conclude that this type of COB LEDs do actually have a temperature and over temperature protection. So when it senses that it reaches a temperature higher than the one it's designed to work in, it diminishes the current demand, as can be seen in this column, and this causes the electric power consumption to drop. These are the two temperatures measured. These temperatures have been normalized at 25 degrees centigrade, and the conclusion is that this kind of heatsink cannot be used for this kind of LEDs without a fan, both because it reaches temperatures way higher than the ones normally recommended for LED operations, and also because this causes the LED to actually consume less power and therefore emit less light. For both cases of the fans, the temperature is lower for the 40 CFM fan in comparison to the 20 CFM fan as expected, but the power draw is almost the same. So in this kind of operation, if you want less noise, you can use the 20 CFM fan, and if noise is not an issue and you want a lower temperature, you can use a 40 CFM fan. And that's it for this week.